Okay, this is the first lesson in our new unit. In this unit, we're going to look at logic, and we're going to look at the CPU and the fetch execute cycle. Okay, before we start working on things like logic and the fetch execute cycle, it's going to be really important that we look at the history of computing. We need to understand how computers have changed over the last 70 years. Okay, so that's what we're going to do in today's lesson. Alright, so I'm just going to start you off. I'm going to give you a minute. I want you to pause the video, and I just want you to see if you can match the famous computer scientist with their name. Okay, so you've got to just make sure you pause now. Okay, so hopefully you've just been waiting around for a minute and you've matched up who is who. Okay, so we've got this person over here. Alright, this is of course the very famous Alan Turing, okay, who we call the father of computer science. Okay, the father of computer science was actually a mathematician. Okay, next to Alan Turing is Charles Babbage, and we're going to talk about Charles Babbage and his impact on computing very soon. Okay, now I'm sure you recognize number 3, the man next to Charles Babbage. Okay, I think still one of the richest men on the planet. Okay, number 3 is of course Bill Gates. Okay, you probably don't recognize number 4. Hopefully you did a little bit of research and see if you can work it out. Number 4 is a man called Gordon Moore. Okay, who is one of the founders of Intel. Okay, and maybe after watching this video you can go away and find out a little bit about Intel and why Intel is really important to us as computer scientists. Okay, and then finally this man over here, you may have seen in the news recently, okay, is of course Tim Berners-Lee. Okay, so this man is Tim Berners-Lee, who created the World Wide Web. All right, which is kind of the resource that's made the fact that we're having virtual school. That only is possible because of Tim Berners-Lee and his creation of the World Wide Web. So, you know, a great computer scientist. Okay, so those are some famous computer scientists. You may meet some of those along the way as you do today's lesson. Okay, I'm just going to give you a brief introduction today. Okay, so what we're looking to do is we're looking to understand how computer systems have changed since their invention in the 1940s. Alright, so we're basically looking to create a timeline to show what's happened to computer systems from 1943 to today. Alright, and hopefully along the way you will find out about Moore's Law, and I want you by the end of your work on this lesson, okay, I want you to see if you, I want you to be able to explain to me what Moore's Law is, okay, and why it's important to computer scientists. Okay, so we're going to move on. Okay, so on the slide, okay, in front of you is the difference engine. Okay, and you can go and see this if you ever go to London. All right, this is at the National Science Museum, okay, in London, and this is basically a mechanical computer. All right, and it was created by Charles Babbage in the 19th century. All right, and it was the first computer. All right, now what's interesting about this computer is, of course, it's not electrical. All right, this is in fact a mechanical computer, but it was designed to do computation. So it was designed to compute polynomial numbers. Okay, so Charles Babbage was one of the first people to design a computer and understand that you could use machines to do computation. Okay. Now this next person is really important because she was a great friend of Charles Babbage. This is Ada Lovelace. Okay, she was the daughter of Lord Byron. Okay, the famous poet that you probably maybe discussed in your English lessons. All right, but she was an amazing mathematician. Okay, and she got really excited when she spoke to Babbage about his invention. All right, and Ada Lovelace was started to get very interested in this. All right, and what she started to do was she started to understand. She was the first person to really understand what this device could be capable of. Okay, so Babbage had just one idea in his head. He had designed it as a solution to just one problem, but it was Miss Lovelace, okay, who was the first person to really go and say, well, actually, this device can do so much more. So Ada Lovelace started to write programs for the difference engine, all right, and she was the first programmer. Okay, and you can still, if you go online, you can see some of the programs that she wrote. All right, and she was the first. She was the first person to really understand what the kind of things that we could do with these computing machines. All right, so make sure you spend a little bit of time just finding out what you can about Ada Lovelace. Okay, so we're going to jump now. So Ada Lovelace and Charles Babbage were around in the 19th century. Okay, so that was really before electricity. So they were looking at mechanical computers. All right, and now we move to the 20th century, and I'm going to introduce you to this man. All right, who is Alan Turing. Okay, now Alan Turing was a mathematician. He wasn't famous, but he was a mathematician. But he was also very interested in Babbage's work, and he was very, very interested in creating devices that could do computation. Okay, and in 1936 he published a very, very famous paper, which you can, if you do some searching on the World Wide Web, you can find it, on computability. All right, and the reason why we talk about Alan Turing being the father of computer science is because he was the first person to really understand what computers could do. All right, and he developed what's called the universal Turing machine. All right, and he proved mathematically, all right, that that there was an amazing amount of things that could be calculated on a universal Turing machine. All right, and basically Turing in his famous paper basically understood that there was just so many things, different things that we could get these devices to that we could get them to do. All right, and he later on published a paper around artificial intelligence and talking about how we could create artificially intelligent computers. All right, and he was really the first person that understood that computers could do much more than just the kind of maths tasks that we had set them to before. And you may not realize this, but Alan Turing is involved in your lives probably much more than you understand, because whenever you're online and you have to complete a captcha code, all right, that's a type of Turing test, all right, and that's a device created by Alan Turing to determine whether a computer was intelligent or not. All right, so do a little bit of research. You can find out a little bit more about Alan Turing. All right, it's quite a sad story what happened to him after World War II, but have a read. There's also some films that you can watch. Okay, so we're going to talk about Alan Turing a little bit more because during World War II, all right, he didn't become a soldier. So basically, what they did is they sent a lot of mathematicians to work at code breaking. All right, at a place called Bletchley Park in the UK. Okay, so there were lots of these mathematicians all together, and their job was to try and crack the German codes. Okay, so the Germans were sending messages to each other, but they were encoded. So the mathematician's job was to try and break the code, and so we could find out what the messages were. All right, so Alan Turing was one of the people involved in this project, and at the time the Germans were using a device called an Enigma machine. And again, you can do some research on the Enigma machine, find out a little bit more about it. There's also some films around it, talk about it. Okay, so the Germans were using the Enigma machine to send messages to each other. Right? Now, the Enigma machine has a huge amount of variation, so there were millions and millions of different combinations that of ways that this Enigma machine could be set up, and so there were millions and millions of different possibilities that this Enigma machine could produce. So Alan Turing's job was to try and crack the Enigma machine and try and work out what the messages were. Okay, and this was one of the first devices that was created, mechanical devices that was created to help them with that. This is called the bomb. All right, and again, you can see this in London if you go to Bletchley Park. Okay, and this was one of the first mechanical devices used to try and crack the Enigma codes. Okay, now later on, not developed by Turing, but Turing was involved in the work. Okay, in 1943, British scientists created this. This is the Colossus. This is called Colossus. Okay, and lots of people would argue that this is the first computer. This was developed in 1943. Okay, it's called Colossus. It used a paper tape. You can see the paper tape over here. Okay, which was used to input data into the system, and also was used to input data to get data out of the system. Okay, and this was the first computer, and it was used to crack those Enigma codes. All right, so this was being used in World War II to crack the German codes. Okay, now what's interesting about this story, so the Colossus was created in 1943, but what's interesting about the story is after World War II, in 1945, at the end of World War II, Winston Churchill ordered all of this to be destroyed. Okay, so no one would ever know what the British and what these code breakers have been doing. And you know, for 30 years after the event, people like Alan Turing and all the people that worked at Bletchley Park were not allowed to talk to people about what they had done during World War II. So no one knew about the work that they've been doing, and no one knew about Colossus. Okay, and all of the technology and all of the work that went into Colossus disappeared for 30 years. No one was allowed to talk about it. Okay, which allowed the Americans to create another computer system around about the same time called ENIVAC. All right, and maybe in your research you'll see some discussion about what was the first computer. Was it Colossus, developed by the UK in 1943, or was it the ENIVAC developed by the US? Okay, so there's a couple of interesting things for you to look at there. All right, so this was part of the Colossus. All right, this is called a vacuum tube, and this was essential to make Colossus work. All right, and computers in the 1940s and 50s, they all required one of these vacuum tubes. They didn't require one of them, they required loads of them. All right, and that's why computers were so big. So if we go back to that picture of Colossus, you can see the kind of size of computer that we're talking about. All right, it probably fits, takes up, you know, a wall of a room. Okay, and that's the reason why it was that size, because of these vacuum tubes that were required. Now these vacuum tubes were not particularly reliable. All right, they used to break quite easily. They were quite sensitive to temperature and light and things like that. All right, so they weren't great, and they were also quite large, which meant computers were really, really big. So if we had continued building computers with vacuum tubes, I don't think we'd be using as many computers as we are today. Okay, so but of course something else comes along. All right, so later on in the 50s, all right, this was developed. Now some of you might recognize this. Okay, this is called a transistor. This is one of the first transistors that was developed. All right, now this is an electrical switch. So this vacuum tube here is basically a switch. Okay, and it's a computer works by basically a computer is just lots and lots of switches, and we're going to talk a little bit more about that as the unit progresses. But a computer is just lots and lots of switches, and this vacuum tube is a form of switch, an electrical switch. Okay, but this transistor again is another form of electrical switch, but it's far, far smaller. All right, so all of a sudden, because of the invention of the transistor, computers that contained thousands of these electrical switches would all of a sudden become a lot smaller. Okay, so the invention of the transistor in the 50s was a really important kind of monumental thing that happened, and it really made a huge difference to the development of computer systems. All right, now look where we are now. Okay, so we have now got computer systems that fit in your pocket. This is the iPhone. All right, and what you need to understand is that iPhone is now, the iPhone that you have in your pocket today is as powerful as a supercomputer from 10 years ago. So the rate of change, the change that's happened over the last 70 years is unbelievable. All right, and I don't think anyone could have predicted that computing technology would change so much over the last 70 years. All right, and that's what your task is. Okay, so you know, nothing else has developed at the same speed as a computer system. All right, Bill Gates once famously said that if General Motors had kept up with technology like the computer industry has, okay, he said we'd all be driving $25 cars that got 1,000 miles to the gallon, and we are clearly not driving $25 cars that get 1,000 miles to the gallon. So the rate of change in computing has just been phenomenal over the last 70 years. Okay, so your job this week is going to be to write that story. Okay, so I want you to find out, using the World Wide Web, alright, I want you to find out what's happened to computer systems since World War II. I want you to tell that story that takes us from Colossus in 1943 to the iPhone in today. Okay, and it's even more obviously this is a great time to be doing this. But Apple have just announced a new iPhone, so tell me the story between 1943 and today. All right. Now, what I want you to do, you're going to create this in a format of a PowerPoint presentation. I want you to make sure that you source all the information that you get. So make sure at the end, the last slide in your PowerPoint presentation, are references. So you reference where you get your information from. All right. And I want you to make sure that you're not just copying and pasting information, that you're writing the information in your own words. Okay. All right. Have great fun doing this activity, and I will see you next week for our second lesson. Thank you.